All right, we're now on 10.2. We're going to do the area of regular polygons. We now know how to find the angles inside those. We will need to know how to find the angle inside of regular polygons so that we can find their areas.
Oh, wait.
All right, we have the area of a triangle. We have done the area of triangles many times. What's the formula for the area of a triangle, just off the top of your head?
Base times height. 1/2 base times.
One half base times height, okay? We can technically break up any polygon into just a bunch of triangles.
Mm-hmm.
What is the, now we have wait, what is special about an equilateral triangle?
The sides are all the same.
All the sides are the same.
So it's 1/2 side squared.
All the sides are congruent, and all the angles also are. So here we go. So if I named one of them S, then they all would be S, correct? And so here is a formula which you have written down for your formula madness. 1/4 square root 3 S squared. We also changed it a little if you wanted to. We named it like this. Let me get a different color. We also said that we could do this square root 3 S squared all over 4 if you wanted it. All right. Is the area. We can write it that way also. All right, so there's a formula that we have for equilateral triangles. Not all triangles are equilateral, but... All right, yes.
Does it matter if the S is a capital?
With that particular one, it needs to be a lowercase.
Oh, okay.
Yeah, it needs to be lowercase. Thank you for asking that question. So if you had an equilateral triangle with the 8-inch sides, where would the 8 go in the formula? As in the place of the S, right? Just a second. I'm going to show you how to do something with that fraction. In the place of this S, we would put an 8, correct?
Yes.
All right. I want you to instead of you putting this into your calculator and let it do everything, you need to realize something that's really going to help you out. This whole thing is one big fraction. These over here are also fractions. They're the numerators of the fractions. And if you'll just multiply all the numerators and all the denominators and put them together, this will be 64. Leave that square root 3 as it is. And times 1, you'll have 64 on the top, correct? 64 square root 3 on the top. And what will be on the denominator? 4.
Question.
You can also going to be able to reduce if you wanted to. So you could at this point, just like before we go any further, you could just write this 64 square root, whoops, my bad, square root 3 over 4, and then reduce the 64 and the 4. Okay? You can reduce after you multiply, or we can reduce before we multiply. What is your question?
If we don't know a triangle is equilateral, and we just do the 1/2 base times height, what's the difference?
You might not know the height. This formula, you don't need to know the height.
Oh.
You only need to know the sides. Okay. So the difference when using the other one is if you have both the base and the height. So if you have an equilateral triangle that you don't know the height of, you don't need it. You won't have to do some fancy trigonometry or something to get that height. Okay? Well, that's a good question. All right, so I'm going to show you also that this would be 64, and you could reduce before you multiply instead. We could reduce the 4 and the 64. 4 goes into 64 16 times. Okay? So you could reduce before or reduce after, either one. We left this as the square root 3 instead of multiplying it all out. You'll just do what the instructions say for your homework. All right, it's inches. Don't forget your inches squared when we're doing area. Don't forget your inches squared when you're doing area. Parts of a regular polygon. You have a picture in your note sheets. Looks very similar to the one I have up here. We have 3 parts. I have written those parts out for you and left some blanks. The center, the radius, and now a new vocabulary word called the apothegm. I'm going to let you fill in the blanks for just a quick minute. Give me a chance when you fill in those blanks, and we will continue after that. All right, let's go over each one of them. The center of the circumscribed circle. If I put a circle around this hexagon, the center of the hexagon would be the same as the center of the circle. I want you to notice that each of the vertices of this hexagon touch or are tangent to that circle. Okay? The radius of a polygon is the same as the radius of that circle. But notice, though, when I draw that radius, I did not draw it coming out here. I drew it to a vertice of the polygon. That is the radius of the polygon. You're going to do it from the center out to one of the vertices. The last one is a brand new one. It's the apothem. And the apothem is going to come straight down. It's going to be perpendicular. You might want to write these down, by the way. You can draw those pictures on your papers about the radius. At least we haven't gotten the radius there on your paper. And the apothem is going to come down perpendicular. On my video you can see it well, but on the screen there we can't see it very well. We're coming straight down. It's going to be perpendicular. And it's going to come down at the midpoint of one of the sides. That's the center of the two consecutive vertices. It's going to be perpendicular, and it's going to be at the middle, at the midpoint. Okay? I'm going to take some of this, I'm going to take these out. Really quick here, I'm going to do something. If I have a triangle, right there. It's coming up. There we go. See the triangle I have right there? What's the area of a triangle?
A equals 1/2 base times height.
In that triangle over there, what's the height?
The apothem.
The apothem, right? The apothem is the height. And the base is one of the sides of the triangle, correct?
Mm-hmm.
If I did that over and over, and I have that triangle, and that triangle, and that triangle, I will have how many triangles?
6.
6 of them. If I found the area of just one of them and multiplied it by 6, I would have the area of the whole thing, correct?
Yeah.
Which would be this, and so this base times 6 is the same as finding the perimeter of that shape. If I knew this was 4, that would make this one 4 because it's regular, and this one 4, and this one 4, and this one 4, and this one 4. If I wanted the perimeter of that hexagon, if I did 4 times 6, I would have the perimeter, correct? So if that 6 times the base here would be the same as the perimeter. Our formula that we're going to draw in a minute is 1/2 the apothem. Times the perimeter, which is the same as finding the area of all of those triangles. Yes, ma'am. You're right.
But right there we have 6 triangles drawn.
Yes.
Before we said we can only draw 4.
Yes. Let me give you a blank thing a minute ago. All right. This is what we were doing. We were doing a little bit. Let's do this. A blank screen here for a minute. And I drew that polygon that I had there. The hex. This is a pentagon. I was trying to cut it into triangles that included the edges, or that had clear-cut triangles. My vocabulary is not working real good. That had triangles that the shared on as much on the base. Right. Let me do another one. 1, 2, 3, 4, 5. We did this one a minute ago. We went like this. Okay, watch this. This does add up to 180, but I'm including an angle that's not one of these edge angles. Do you understand? For this one that I was drawing before, so we could figure out the total number of degrees in the triangle, I wanted to find these edge angles, not these extra little pieces of the angles in the middle.
Okay.
Do you understand the difference?
I think so.
Okay. So let's go back and get our formula. Our formula for finding the area of a regular polygon is going to be 1/2 the length of the apothem times the perimeter, which you have written down, 1/2. You said ap earlier, 1/2 apothem times perimeter. A stands for the apothem. P stands for the distance around the entire thing. Since it's regular, the nice thing is if you know one of the sides, you just multiply it by how many there are, and you'll have the perimeter total. Well, how many sides does this have?
6.
Careful. Not 6.
Yeah.
Not 10.
I'm
8.
sorry, I can't.
8.
I can't.
All
I
right.
said add 2.
So if there's the apothem, it comes down perpendicular.
10 or... Well, if you count like every other side.
Yeah.
And then the perimeter's all the way around. So if I knew the apothem here, and I knew only one of the sides, I could take 4 times 8 to have the perimeter, and I could multiply it by the apothem, and I would be done finding my answer. Okay? All right. We're going to do some examples. We also are going to review 30, 60, 90 triangles. You will need those in the future. We're also going to review some sine, cosine, and tangent, and do some examples. The examples we will do together are 1 through 17 odd. All right, so we're going to do find the area of each regular polygon. It says round your answer to the nearest tenth if necessary. I'm going to put the formula up for me. Area equals 1/2 the apothem times the perimeter. What is the apothem in this diagram? 2.3. So I have my 1/2, 2.3, and the perimeter is what? 24. How did she get 24? Amy, how did she get 24? That decimal should be down there. The perimeter is the distance all around this. If this is 8, this one's also 8, and this one's also 8. So we got it by 8 times 3. I'm going to write 8 times 3. And I am going to give you some tips, because 2.3 is a decimal, so it's very likely you're going to use your calculator. I am going to give you some tips on how to put this in your calculator one time through and not have to hit equals a whole bunch of times. I'm going to suggest that you do the numerator, all the numerator at the top, and then divide it by 2 at the bottom.
I can't just do 1/2 open parentheses.
You can. You can do it that way. I'm not suggesting that. You can do it that way. I am suggesting that you do the whole numerator and divide it by the denominator. So I'm suggesting that you do, the 1 is not necessary. Then I'm suggesting that you do the 2.3 times 8 times 3 divided by 2.
But 8 times 3 would have to be in parentheses, correct?
No.
No?
Because
That's true.
multiplication is commutative and associative.
I got 9.545.
Divided by 2? You already divided your 2?
Yeah.
Okay, so what did anybody else get?
Not what I got.
Something like 27.
27.6.
Okay. Fantastic. Number 3, find the area of this regular polygon. Again, its area equals 1/2 the apothem times the perimeter. What's the apothem?
11.7.
And the perimeter
11.3.
times.
7.
Very good. Again, I'm going to suggest that you do the numerator and divide by the denominator. One more time. 400 and what?
462.7.
7. All right. Thank you. Let's move. This time there is no diagram. It says it's a triangle. It tells you the apothem and it tells you the side. 1/2. Area is 1/2 the apothem times the perimeter. We have 1/2. What's the apothem?
5.
What's the perimeter?
Oh, wait a second.
17.3 times 3.
How did you decide that?
The triangle.
Because it's a triangle, so we're going to multiply that by 3. Make sure you know the names of your sides. If it says pentagon, hexagon, you have to know how many sides that is. We got 129.8. All right, let's move on to number 7. A nonagon. How many sides is a nonagon?
Whoa.
Wait.
9. All right. So area equals, just second, 1/2 the apothem times the perimeter. The apothem is 10. The perimeter is what?
Oh yeah.
Thank you.
Oh, okay. Yay. She's copied on my answer.
We're doing number 7 now, though.
I am.
So
7?
tell me what you got when you got what you have your answer. 328.5. Is that what I heard?
Yep.
Yeah.
All right, fantastic. We're going to review now our 30, 60, 90 triangles. I'm going to draw your 30, 60, 90 triangles. What is the relationship between the legs and the hypotenuse? What was the little letters that I'm supposed to put up there? A.
A square 2.
Very good.
You know you could.
So this time, if we know the hypotenuse, what do you have to do to get the leg on this number 9?
You have to divide by square root.
That's correct. We have to divide by the square root of 2. Oops, that's a crazy one. I can't leave it like that.
Yeah.
I have to rationalize. What is this denominator square root 2 divided by, square root 2 times square root 2 going to become?
4. No. 2. Sorry.
Yep, square root of 4, which is 2, that's correct. 2 square root 2 over 2. Am I finished?
No.
No, because you can get rid of the 2.
Yes, and leave you just with square root 2. All right.
So this, yeah.
All right.
I cannot.
Let's move over to number 11. All right. So, what do I write here for the 30, 60, 90 triangle? If this is the 30, what goes with what?
It goes across from it.
Okay.
2a goes on the hypotenuse. A square root 3 goes.
Fantastic.
Wait.
So,
Wait, what?
what do I have over here? Do I have on mine? Is that a square root 3? Is that like the a, the 2a, the a square root 3? What is?
Wait, which one?
Okay. The 8 square root 3 is the a square root 3.
And that's fantastic.
That is fantastic.
That means a is what?
8.
Which that is that x or y in our case?
Y.
That's correct. So this is 8.
And then so y would be 6, or x would be 16.
Yes, just double it.
That's easy.
This particular one.
That one is, yeah. The rest of them aren't going to be.
We will be seeing these next
They
week.
did it again for 12. It's the same thing.
Good. We will be seeing these next week when we do. Listen, when we do more.
Not the same numbers, but it's the same
When we
type.
do more of the area, we will need these triangles. So make sure you understand how to do that.
Oh, wait.
No.
Hey.
13. Find the missing side. We have an angle. We're looking for a side, and we have another side. We're going to use either sine, cosine, or tangent.
Tangent.
I heard tangent. This is the opposite. This is the adjacent. Opposite and adjacent, yes, are tangent. Tangent 70 equals what over what?
X over 15.
How do I solve that for x?
X equals 15 tangent 70.
Move the 15 up. Yes, fantastic. 41.2 is what we got. Let's move on to number. All right, is this sine, cosine, or tangent? We have the adjacent,
Cosine.
and that's the hypotenuse. Adjacent and hypotenuse is cosine. So cosine of 21 equals what over what?
16 over x.
Uh-oh, the x is on the bottom. How does that help? What do we do for that?
X equals 16 over cosine.
So I flip the cosine and the 21, cosine 21 over x. I flip them. I'll have x equals 16 cosine 21. That's those means and extremes that we're allowed to switch when we have proportions. This was a proportion because it was like over 1. And we just put in our calculator, x divide cosine 21.
17.1.
17.1, is that correct?
Yes. What'd you get for 14? 4.
Last one together, we're doing number 17. Is this sine, cosine, or tangent?
Tangent.
I heard tangent. This is the adjacent. The opposite and the adjacent. is tangent. Tangent 35 is what over what?
10 over x.
Good job. What do I do to solve that for x?
Would be x equals 10 over.
Yes, good job. I flip those. X equals 10 tangent 35. Put that into our calculators.
14.3.
I heard 14.3. Is that correct?
That's what I got.
Fantastic. All right, let's review what we've done. You learned the parts of a polygon. You learned that you had a radius, center, and now a new vocabulary word, an apothem. You can now find the area of a regular polygon using the new formula, the 1/2 apothem times perimeter. You also can find the area of an equilateral triangle with its formula, the 1/4 square root 3 s squared. And I hope this has been helpful. Goodbye.